Okay, this is the same situation. We still have a board game, still have the exact same numbers, it's just two more questions. So number 3 says a student draws a number divisible by 3 and then a 1. Okay, so numbers that are divisible by 3. Let's hang on for a second and think about that. So 1, can you divide that by 3? Well, yeah, you could, but it'd give you a fraction or a decimal, so that's not what they mean. 6 divided by 3. Okay, yeah, that gives you 2. Okay, 6 divided by 3, 2. 9 divided by 3, yeah, that's 3. Okay, 2 divided by 3, no, that's a fraction. 1, no. 6, yes. 2, no. Okay, so now let's look at this. How many events do we have in the first problem? Student draws a number divisible by 3, then a 1. Okay, we have 2 events. A number divisible by 3, that is event number 1. And then a 1, that is event 2. So we're starting all over with this. We put the cards back from practice problems number 1 and 2. So we have 1, 2, 3, 4, 5, 6, 7, 8 total for event number 1. And a number divisible by 3. Okay, well, we just went through those. Which ones were they? 6, 6, 3, and 6. So how many numbers are there? How many favorable outcomes do we have? 4. Okay, but then one of those cards does not get put back. Doesn't matter which one. Let's just say, I'm going to do it in pencil this time. Let's just say this 6 right here, I don't put it back. That's what I got the first event, and it doesn't get put back. Okay, so now event 2, I need a 1. Okay, well, how many 1s do I have? Here's 1, and here's 1. So that's only 2 favorable outcomes. But, and this is the big deal with dependent probability, do I still have the same number of cards? No. Remember, I didn't put this card back. So now, instead of 8 cards, there are 7 cards. Okay. Once you have your 2 probabilities for event 1 and event 2, to get your answer, you multiply. So I multiply straight across. 4 times 2 gives me 8, and 8 times 7 gives me 56. Okay, but then that's not my final answer. I need to simplify. Okay, so what can I simplify by? They're both even numbers, so I could divide them both by 2, but there's an even better option. Okay, if you get stuck, you can simplify as many times as you want. If you want to keep going by 2 and then by 2 again, then by 2 again, that's fine. The largest number that goes into both of them, though, that will give you the least number of steps. So I see that they are both divisible by 8. If I divide this one by 8 and this one by 8, I will get 8 divided by 8 is 1. And 56 divided by 8 is 7. Okay, so I get 1/7. Remember I told you the other way, though. You can simplify before you multiply. Okay, so what can I simplify here? Okay, 4 and 8. Those are both divisible by 2. They're even numbers. Actually, even better, they're both divisible by 4. 4 divided by 4 gives you 1, and 8 divided by 4 gives you 2. Okay. So then you would have 1/2 times 2 over 7. Okay, but you can simplify again. Remember, it's any top with any bottom. And there's no limit to how many times you can simplify. There's nothing that says you can only simplify once. So this 2 and this 2 doesn't matter. It's, like I said, any top with any bottom. 2 and 2, they are both divisible by 2. And remember, if you have the exact same number, they basically cancel out. 2 divided by 2 is 1. 2 divided by 2 is 1. So they both go to 1. So now you are left with 1 over 1 times 1 over 7. Multiply straight across. 1 times 1 is 1, over 1 times 7 is 7. So you get the exact same answer. It really depends on you as to when you simplify. In this case, I think this way was a little bit more trouble than that way. Okay? Usually I would say do it this way because they're smaller numbers. Okay, but if you knew 56 divided by 8 was 7, then this way would have been the better way to go. Okay, so let's look at number 4 now. A student draws a 1 and then a 6. So, draws a 1. That is event number 1. Then a 6. That is event number 2. And we put that 6 back. Everything goes back to normal for event number 1. There are 8 total cards. And how many 1s are there? Okay, here's a 1 and here's a 1. So that means that there are 2 favorable events or outcomes. And then event 2 is a 6. Okay, so how many 6s do I have? Here's 1, and here's 1. So that's 3 favorable outcomes. But how many total do you have now? If you got a 1 that first time and you did not replace it, that means that your total for the second event is now 7. That's 1 less because you didn't put that card back. So that is your table. Now all you have to do is multiply and simplify, or simplify then multiply. Okay, I'm going to do it this way first. I multiply straight across. 2 times 3 gives you 6, and 8 times 7 gives you 56. Okay, I can simplify that. They are definitely both divisible by 2 because they're even numbers. Let's try that. 6 divided by 2 is 3. And 56 divided by 2 is 28. Okay, and can I simplify that? Doesn't look like it. There's no number that goes into both 3 and 28. Okay, let's look at it this way though. You have 2 over 8 times 3 over 7. What can I simplify before I multiply? Okay, 2 and 8, definitely, just like I did in one of the other ones. They're both divisible by 2. 2 divided by 2 is 1, 8 divided by 2 is 4. So now I would have 1 over 4 times 3 over 7. Okay, there's nothing else I can simplify, so I multiply straight across. 1 times 3 is 3, over 4 times 7 is 28. And we get the exact same answer. Okay, I think I have a few more just a couple more practice problems for me to do for you.